Hello everyone, welcome to Chemazon-Complete Chemistry. So this boy has one small problem. He knows that a given reaction is a substitution reaction, but he is very confused whether it is going to be SN1 or SN2 reaction. So that is what we are going to see in this video, how to identify. It is given to us that a particular reaction is a substitution reaction, and we have to identify whether it will be SN1, it will follow SN1 mechanism or SN2 mechanism. So let us get started. So these are the different alkyl halides. Before understanding this, the very first step is you have to check for the formation of a stable carbocation. Okay, formation of a stable carbocation. Okay, whether there is formation of a stable carbocation, for example benzylic carbocation or allylic carbocation or tertiary butyl carbocation. Okay, these are what stable carbocations. Why these are stable? Let us see the reasons. Here this is stabilized by resonance with the pi electrons from the benzene ring. Then this is also stabilized due to resonance. This is stabilized due to, we had seen in the last video, this is stabilized due to two factors. One is inductive effect and hyperconjugation. So if a stable carbocation is formed, whether it is primary, secondary or tertiary alkyl halide, okay, where whatever alkyl halide is present, if anyhow by rearrangement, okay, if let's say first a less stable carbocation is formed, let's say primary carbocation, for example I have CH2 plus. So suppose initially this primary carbocation is formed which is less stable, so you might say this is less hindered and you might mark the answer as SN2 mechanism. As it is less bulky, then your answer would be incorrect. Why? Because here what I can do a rearrangement that we are going to see in the next video. What is rearrangement and what are the different types of rearrangement? So I'm doing 1,2 hydride shift, and as I do 1,2 hydride shift, this CH2 will become CH3 and this will become a stable carbocation. So always remember, if after rearrangement a stable carbocation is formed, then always which reaction will take place? Whenever there is a formation of a stable carbocation, we know SN1 reaction. In SN1 reaction, carbocation is formed. Okay, so whether it is a primary, secondary or tertiary alkyl halide, whatever is the alkyl halide, you don't have to see the alkyl halide first. First you have to, what you have to do is remove the leaving group, check whether the carbocation is stable or not. Okay, if it is stable, then always SN1 reaction, or if it is a elimination reaction, E1 reaction will take place. This we will see later on. So always one, okay, superscript 1 or one type of reaction takes place whenever the carbocation is stable. Okay, suppose if there is no stability in the carbocation, then you check for the alkyl halide. Okay, then you check for the alkyl halide. Now primary alkyl halide, okay, 0 degree alkyl halide CH3X or RCH2X. This we had seen, these are what? These are less bulky. Okay, so it is simple, it will follow which mechanism? SN2. Now if there is a tertiary alkyl halide, okay, this is what, this is here a stable, this stable carbocation will be formed, so this will follow which mechanism? SN1, right? So the most important part here, it is going to be a secondary alkyl halide. So whenever there is a secondary alkyl halide, that is this third one, okay, this secondary alkyl halide, then what you have to check is here, it is very very important, you have to check the solvent. Okay, if the solvent is what? It is a polar protic solvent. Okay, we had seen in the last video, this favors what? This favors SN1 mechanism. If a polar protic solvent is present, SN1 reaction takes place, and if a polar aprotic solvent is present, then SN2 reaction takes place. Okay, what is the example of a polar protic solvent? I'll write here. Polar protic means the one that can donate H plus ions. Okay, examples are water, alcohol. So the examples of polar protic solvent are water, alcohol, or amines. Amines can also donate H plus ions. Okay. So polar protic solvent, and what are the examples of polar aprotic solvent? Are these examples. It can be acetonitrile, dimethyl formamide, acetone, DMSO, 18 crown 6. Okay, these are some of the examples of polar aprotic solvent. So polar protic solvent will favor SN1 mechanism. Okay, and polar aprotic solvent, all these solvents will favor SN2 mechanism. Okay, so I hope this is very clear. First step, what you have to do is you have to check for the stability of the carbocation. If the carbocation is stable, always SN1 reaction will take place. Then you have to check the alkyl halide. Okay, if it is primary, then primary or 0 degree, this is 0 degree, or primary, then what will happen? SN2 reaction takes place. If it is a secondary alkyl halide, then what you will check? You will check the solvent. If it is a polar protic solvent, then SN1 reaction takes place. If it is polar aprotic, aprotic means the one that cannot donate H plus ion, so that will be following SN2 mechanism. So what are the example of polar protic solvent? Water, alcohol, amines. Polar aprotic solvent, all these examples. Okay, and tertiary alkyl halide, we know carbocation is formed, so it will follow SN1 mechanism. So now let us try to understand this with the help of some examples. Now here you can see this carbon. What is the question? The major product expected from the reaction below is. So now Cn minus. Okay, when substitution reaction takes place, when one particular species is small in size, okay, small in size, so that it can easily undergo nucleophilic, it can easily act as a nucleophile and attack the alkyl halide. It should be small in size and lots of electron density. It should be electron rich. Okay, lots of electron density must be present. So here Cn minus is what? We know carbon and nitrogen both are small in size. So it will act as a nucleophile. So it will not act as a base. So where alkene is formed, that is elimination products, they are completely incorrect. Now what you have to check is whether the carbocation formed is stable or not. So let us draw the carbocation first. Draw the alkyl halide. Br. Leaving group goes away as a Br minus will go away as a good leaving group. So what we have got is a stable tertiary carbocation. Okay, this is a stable carbocation. So this will follow which mechanism? SN1 mechanism. So here what will happen? Substitution reaction will take place. Cn minus will attack. And what will be the final product? The final product will be CH3CN. Okay, option B is incorrect because we know methanol here is what? It is not a nucleophile. It is a solvent. And you can see it is a polar protic solvent. It is an alcohol, right? So we know polar protic solvent favors SN1 mechanism. So this is another proof that it is a substitution reaction. So what is the correct answer here? The correct answer will be option A. Okay, now let us see this next one. Here this is very simple. What is a leaving group in the following reaction? So OH is replaced by Cl. Okay, so which group goes away as a good leaving group? OH minus. Okay, so what will happen here? It is, we'll see whether it is OH minus or something else. CH3, CH2. Okay, oxygen has lone pair, so it will attack H plus ion. Cl minus will go away as a good leaving group. CH3 CH2OH H positive charge. Now what will happen? This will leave the molecule. So which group is leaving the molecule? It is water molecule minus H2O. So here the leaving group is what? It is water molecule. Okay, and then what will happen? At the same time, this is a primary alkyl halide, right? So which mechanism will be followed? SN2 mechanism. Okay, this is the nucleophile here. Okay, so what is the leaving group here? The correct answer is water. Okay, now this is the last question. So now suppose this is what? This is a secondary alkyl halide. Okay, Br is above the plane. Hydrogen is below the plane. So suppose you attack CH3OH. Okay, you might say that this will attack and Br will go away as a good leaving group. And what we will get is the inverted product. This is above the plane. So CH3OH will attack from below the plane. Okay, we know there is inversion of configuration. So you might say this is R. So this will be 1, 2, 3. Fourth priority group is on the wedge bond. Okay, 1, 2, 2, 2, 3. It should be R. But the fourth priority group is on the on the wedge bond. So the correct answer will be S. So you might mark only S. Okay, and that would be incorrect. Why? So very important. I had told you what you have to check is here it looks like a tertiary alkyl halide, but it is what? It is a primary alkyl halide. Because of wedge and dash bond, you might think it is a tertiary alkyl halide, or in a hurry you might do SN2 mechanism, which is incorrect. Why? Because you can see carbon is attached to two other groups. Carbon attached to halogen is attached to two other groups. So this is a secondary alkyl halide. So I told you what you have to check is solvent. What is a solvent? Solvent is methanol. So here methanol is acting as both nucleophile as well as solvent. Okay, so what will happen? This is what? This is a polar protic solvent. Polar protic solvent. So which mechanism takes place? SN1. Okay, so here both the enantiomers will be formed. Okay, pair of enantiomers will be formed, R and S. So the correct answer here, it will be R and S. That is the third option. So this is the end of this video. I hope you have understood how to approach this problem, whether it is SN1 or SN2. First check the carbocation, then you go for the carbocation stability. If it is stable, then it will be SN1. Okay, all the three examples of stable carbocation I have shown you. This is what? This is first one is, this is benzylic carbocation. Okay, allylic, and this is tertiary butyl carbocation. Okay, so in all these three cases, always SN1 mechanism is followed. Okay, then you check the alkyl halide. If it is primary or 0 degree, SN2. If it is tertiary, SN1. In case of secondary, you check the solvent. Polar protic solvent, SN1. If it is polar aprotic solvent, SN2. So I hope you have understood this. Thank you.